decision to make. This talk is standardizing product lifecycle with DBT macros. Hopefully, it will show how analytics engineers can add value to a business by thinking of their outputs like a product in order to simplify complex analytics. I'm going to be saying the word product an awful lot in this talk, so if you have an aversion to that, apologies, maybe you want to go next door. Right, hi, this is me in a slightly bolder outfit than what I'm wearing today. The text is really small here, but I'm currently a staff BI engineer at Travelperk. But when I did this piece of work, I was actually at another company called Dojo, where I was an analytics engineer. So hence why I'm talking about analytics engineering. I do know what it is at an analytics engineering conference. But yeah, first of all, Dojo. Why did Dojo have this problem? In essence, Dojo offered an awful lot of products to an awful lot of different customers. And that's kind of why we had to think of this solution. Let me explain that a little bit more. So in premise, Dojo, this is Dojo's little logo, in case you can work that out. Dojo is primarily a face-to-face card machine payments provider. It also provided other ways for businesses to take payments as well. So you could do it either via an online store or via customized payment links. Those businesses could then extract information from Dojo's app about their invoices, as well as some insights into their reporting as well. One behind. As well as all of that for a customer-facing business, they also offered an app to consumers, allowing them to access nearby restaurants. So lots of different users, lots of different products. I could go on about Dojo, but I'm not trying to sell it. I'm trying to say what we did as a solution. Part of this came about because of Dojo's mindset. So they were very much a product-led mindset. I'm sure this phrase has been spoken about, or product with a capital P is often sort of said as well, all of that kind of rubbish. It's essentially about creating a lot of different products in order to stay competitive against the market. Where this becomes a problem, though, is when data teams don't have a standardized approach to dealing with this. So before I did this piece of work, all of the data was modeled independently for every single product, and there was no consistency in how numbers were reached or principles and sort of how things were done. And as you can imagine, that was chaos. There we go. What it meant is that simple questions became really, really difficult to answer. So we get stakeholders asking us questions like how many users are active on product X, or what is that as a percentage of those that are eligible, and how does that compare to last month? And if you ask two different people with the data team, they'll probably give you two different answers. So it was probably about time that we found a solution to this. Now, when we started thinking about this, the first thing that we were trying to sort of work out in terms of how to standardize this is what common ground is there across all of our different products. This was the starting point for this piece of work. So it might be stating the obvious, but apologies, this is a talk. But in all products, there's an element of using the product. So we want to know who is using the product and who was using the product, but is not right now. That number becomes more relevant when it's relative to who can use it. As by default, some products are enabled to all users, but others are not. Others apply an eligibility criteria. In this case, we want to know who could be using the product. Then there are also products that require eligible customers to make an application, and there's an onboarding process where they could be either approved or declined. In this case, we want to know who wants to be using the product. Often here as well, marketers would send out some comms to those that are eligible, prompting them to apply if there is that process in place. With these questions, we ended up coming up with 4 commonalities in the lifecycle stage. So, eligible for the product, aware of the product, onboarding on the product, and enabled on the product. And that final enabled step, we divided into 3 subsections, which were active, inactive, and dormant. One complexity, though, is that those stages don't necessarily suit every product. As I said, some are enabled by default, some you had to apply, and it all varied from product to product. So product ABC here has those 4 stages we talked about, but XYZ, or Z, only has 2 stages. So in our solution for standardizing this, we kind of needed to be aware that different products had different use cases and that one size doesn't really fit all. So, the juicy bit. I'm going to talk through this solution in sort of steps, how we dealt with this. The first bit to be aware of is all those stages. Dojo wasn't great at having that all in one place. So the first thing we had to do was kind of get all of the data together in one area and follow a standardized schema for all of those stages. What that looked like is like this. So this is an example of product ABC with 2 stages, an enabled stage and an active stage. For the enabled stage, we can see 2 users going in and out of being enabled, or one being in and out of being enabled and disabled, another user becoming enabled with a timestamp. And the active stage, we're talking about some transactions here. So the user doing some transactions with a monetary value, indicating activity. We then union those 2 tables together, and that becomes our full event log, essentially, for a product. So all users and all the events that are relative to that product. If this was a different product, they might have different stages involved. It might be, I don't know, an email being opened to show that they're aware of it, or an application being started to show that they're intent on using it. That table we want to aggregate. And to do this, that full event log we want to aggregate, and to do this, we used an awful lot of DBT macros, like a lot. So many lines of ginger. Now, I'm going to walk through most of that macro code today. Some of it might be a bit rubbish to see on a screen, apologies. All of it is online, and I'll share a link later to where you can actually see it if you want to digest it in your own time, so don't worry about having to photograph it or write it all down. Right. I find it easier to kind of visualize this stuff if you know your desired end outcome, and this is where we wanted to get to. So this is a user by month table with a load of sums, counts, Boolean fields assigned to a user about their status on that product at that point in time. Hopefully, if you're a data scientist, a BI developer, data analyst, product manager, whatever you are, hopefully you can see the value in having a table like this about product information. When thinking about building something like this, I tended to think of it in 2 separate parts. The first part is quite simply all users by a date. Really simple, that doesn't take much to explain. And the second part is all of this product information. And this can expand horizontally out to here, maybe out here, who knows, with loads of different fields about all the products and that user at that point of time. Let's talk about the first part, first of all, though. This all users by a date table. Now, here this is set at monthly, but ideally we want the flexibility to be able to show this daily, weekly, quarterly, whatever applies to that particular product or that particular use case. Now, in the final macro, I ended up using a variable called time granularity, which you could either set to day, week, or month. I never bothered doing it for any more because we didn't have any use case, but you can in theory do that for anything. Now, if we're looking at something on a daily level, there are obviously more days than there are months in the same amount of time. So that leads to some potential exponential complexity. The way we dealt with that, so this is the first of many ugly slides, apologies. The way we dealt with that was essentially some if statements, that if the time granularity we're looking at is daily, we're only going to go back 90 days in time, weekly, 70 weeks, monthly, 18 months. And we use that time period as the base of our date spine, so we basically get every single day in that time period, or every single week, or every single month in that time frame. We tested this initially of doing the same kind of date range for all different granularities, but daily was too much and BigQuery blew up a little bit, so that's why we restricted it. With all of our dates, we can then cross-join that to all of our users, and that becomes our base table. Dojo had a little bit of a complexity that I don't know if that's relevant to any other people here, if you're considering doing this or not, but Dojo had different definitions of what a user could be. It could be a customer, because they're a B2C customer. It could be a user inside that customer, or it could be a consumer. There are multiple different user IDs, essentially, that we could be interested depending on the product. So we kind of used another variable called granularity to say if it was a user, a customer, I can't even remember what else it was now, but loads of different things. If that doesn't apply to you, don't worry, just think of it as a customer ID. So all we do is just cross-join that to all of our dates, and we have the first part of our table, our all users by time. And this can become really, really flexible by being at daily, weekly, monthly level. Now, for part 2 of our planned table. As we said, this is all the aggregated fields about that user at that point in time on that product. I found the simplest way of looking at this was by the stages that we were talking about earlier. So if I just divide this up, we've got 1 field about the enabled stage and then 4 fields about the active stage. As I said, if there's more stages here, this table could grow horizontally. I just can't fit it all in the slide. Ideally, we can calculate all of these fields from the same SQL query in order to make it more dry and more efficient. To do this, we need to know what stages are relevant to a product, because as I said, they can vary in terms of what's applicable. To get the products that are relevant, all we're doing is just running a select distinct query, I don't need to explain that, from our product lifecycle event table. So all of those logs, we're just taking out all of the distinct events in that, and we're getting that as a list. And with that list, we can then iterate over that for our SQL query. To calculate all of those aggregated fields, my opinion is these should be done in CTEs. Makes code a lot cleaner, easier to read. Some people disagree about CTEs, but for this, do CTEs. Now, CTEs are really easy to handle as long as you know the name of them. But because we're doing this inside a for loop, we had to keep track of the names. So all I did was every time I started a CTE, I appended the name of it to a separate list, which I'll then iterate over later on, and I'll show you that in a bit. Inside the CTE, sorry, some more really ugly text, we're running a select statement, very similar to this, where we're grouping by the granularity ID, so the user ID, customer ID, whatever it is, and the time granularity. And then we're either doing some sums, counts, and you can do some case whens here to say, are they active or whatever it might be. Now, an additional complexity here is if you think about those different stages, what we want to know. So if you think of a customer being enabled on a product or not, whether they were enabled 6 months ago or today doesn't really matter. They're still enabled. They're enabled until they become disabled. Whereas an active user, for what activity they're doing, you only want to know that for that particular time period. So we had to do some separate joining logic depending on the stage. So if it was active, we're only joining on that specific time period, whereas if it's for every other stage, we're looking at everything previous in order to capture the logic correctly. Now, active is a contentious word amongst a lot of product people. They will often give you very varying ideas of what that actually means. When we were initially sort of scoping this project out, we had some people saying, but this product is only to be used monthly, like it's only doing their invoices once a month, so activity should be 30 days, whereas this one is to be used daily, so active should be 7 days, whatever it might be. Can be a little bit complex, so we decided to make it flexible in terms of what an active definition was per product. So we used a separate macro here to give it a product name, and it either gives you the default, or if something's been configured, it gives you customized variables for an active max days and an inactive max days. All of it, though, is standardizing the process to make sure that the output is still following the same pattern. It's just that the date ranges will vary a little bit. If all of your products kind of follow the same active frequency, just hard code these values. It's a lot of extra faff, but for Dojo, it kind of made sense. Inside the main macro, we can then call this, and it returns our active days and our inactive max days. Let me explain a little bit about how that works. So if you consider this timeline, where we have day 0, 30 days ago, 180 days ago, imagine there are defaults. We have our active range as 0 to 30, inactive as 30 to 180, and then anything beyond that is considered dormant. Now, this becomes a little bit tricky when we're thinking about inactive and dormant users from a SQL perspective, because it can be quite hard to do that inside a single query. And it's really long, the SQL I ended up writing for this, probably inefficient. So I'm going to represent this a little bit visually instead. But in premise, to calculate inactive, we need to calculate everyone who's in the active and inactive cohort. So everyone who's active from 0 to the inactive max days 180 days ago, in this case. We also need to calculate the active group as well, so everyone who's in that 0 to 30 cohort. And what we then do is essentially a null join. So we have the active and inactive, and just the active. And if we remove the active via a null join, we get our inactive group. We can then repeat that process for the dormant as well. Yeah, we can repeat that process for the dormant cohort as well, doing the full range and just subtracting the active and inactive group. Finally, we can then start to bring all of this together. So because of our neat little CTE naming list that we found earlier, we can just loop through all of our CTE names and left join onto our base table and select every field apart from the user ID and the date from those CTEs, and that becomes our final select. And that is how we end up with this table. We have it, woo, everyone cheer. So what did we end up actually doing practically with that table? We used Looker as our reporting tool, and I'll go through that, how we used it in there first, but we also had some different use cases. So within just 3 clicks, we could create this very pretty, definitely not accurate graph of product ABC and products XYZ, all on the same graph showing a weekly active user rate. This is really, really useful for product managers to be able to keep track of their long-term KPIs, as well as for data teams to be able to spot neat little inaccuracies in data when there could potentially be problems at any point in the data funnel. But also, as well as this, it wasn't just necessarily weekly. We could also look at from launch as well. So if 2 products launched at different times, say a year apart, but were aimed at a similar kind of process, we could show weeks from launch and a number of active users or enabled users on that platform at that time. As I said, though, we didn't just use this for Looker and a reporting tool. We also used it as a feature store for data science. So it became a really key component in a cross-sell project that they were working on to be able to see all of this product information and help train their models. But as well as this, we also used it in a marketing tool called Braze that we used. Braze, if I don't know, just like any other marketing tool really. You can have all of your users inside the platform, and then this is just a stock image, but you can apply filters to it to create subsegments, and with that, send out your comms. So here we are passing through all of that product level information. So it meant that marketers could create more bespoke campaigns to those users that were active, now inactive, or had just become eligible, or had recently responded to an email about X product, and data science think that they might respond well to another product. All of these things, it allowed marketers to have much more faith in the data that was coming through, because it was all from one source about all of our different product information. I'm sure there are other use cases for this kind of data we're producing here. If you find any, let me know, come talk to me, I'm sure, or talk to the Dojo people actually, they're the ones implementing this. The last thing is do as I say, not as I do. I've definitely made a lot of mistakes in this process. And I think it's important to share these, because if you're implementing these, hopefully you won't fall for the same things that I did. The first point is about finding the right balance between flexibility and standardization. These two things are opposing in premise. You can't really have one without the other. But I spoke a lot about how products can differ in their nature. And ultimately, if you're making a data product for consumers to use, it needs to be useful to everybody. It can't just be useful for one subset. You might as well make it really, really specific for that group. So the process that you're trying to make with these macros is to make sure that it can be flexible enough to suit all parties. That's why we spoke about the active days being different per product. It meant that users could be happy, but ultimately the data is still flowing through the same process. It's going through the same macros, it's outputting the same data in the same schema with the same names. It's just the process of it is slightly different. Now, the end user, stakeholder in Looker doesn't need to know that. They just see an active user rate for their product. That's all they care about. And it's calculated the same way as another product in another part of the business. The next point is about collaboration. I definitely had a lot of help on this product. Manuela, Maria, Chris, Kavia, a load of other people as well. Thank you for help on this. But it's about finding the right people to collaborate with. As I said, there's an awful lot of opinions, and particularly in the product world, product managers can get a bit tetchy about what they own and don't want things to change. So it's about communicating with them why we're doing this process and what it's going to improve, and getting their opinions on about how to do that, but not involving too many people, because you don't want too many opinions to muddy the water about how you're thinking. You want to get a clean, concise user group and get the right information from them. I'm not asking product managers how they want this data modeled. That's our job to decide that. I'm asking them for input on their products by getting the right information from the right people. And the last point is about consider the usability of the product you're creating. Data, in this case, are creating a data product. I said I'd use this word a lot. In premise, you need to think about how and who this product is going to be used by. So for me, there was two different aspects to it. There was the analytics engineers who've got to use this macro, who've got to fit a certain schema, got to do all this kind of process. And there's also the stakeholders, how they're going to use this in Looker, how a marketer is going to use this in Braze. Think about these things as early as possible. When I started this process, it was very much start to finish. How do we start out writing this? And it's the wrong approach. Think of how you want your end users to be using this, and then work backwards from there. It makes it a lot simpler to work that way, but also when you actually end up rolling this out, it makes the whole rollout process a lot simpler because people are already on board. You've already thought about how they're going to be using this, and that's pretty much the only way to go. That's it, really. Thank you for listening. Sorry for interrupting your lunch. I hope you've enjoyed it. As I said, there's a QR code here for the link to the code that I wrote. It's in the Medium article, and there's also a link there. If you have any questions, feel free to reach out to me on LinkedIn or here. I'm here all day, so thanks for listening.